All right, welcome to your brief reteach going back over Unit 8 items. First of all, the screen that you're currently looking at is what I have posted in Google Classroom for Unit 8. If you, for some reason, need to remind yourself of the information that was in the tropical weather slideshow, that's available to you. Okay. That's there. You've also got your slides for weather basics, and you'll need to be able to go back through these. You also have Unit 8, Lesson 1 and 2 guided notes. Your guided notes are actually run off on a yellow sheet of paper, but you'll need to get those together. Remember some of the things from the notes that you may have been asked on the test. The Earth's surface is not heated evenly, and there are 3 reasons. Some areas receive more direct sunlight. The equator receives the most direct sunlight from the sun. Some areas receive sunlight for more hours than other areas. And the other reason why the Earth's surface is not evenly heated is because land and water heat up differently. Water heats up but cools down slowly. Land heats up and cools down quickly. Wind is created as air moves from high pressure to low pressure, and winds are named by the direction that they blow from. 3 major wind belts that we learned were the trade winds that blow from east to west near the equator, the westerlies that are kind of between 30 and 60 degrees north, 30 and 60 degrees south. They blow from west to east, and then we've got the polar easterlies as well. Your trade winds, westerlies, and polar easterlies are all considered surface winds. They act at the surface of the Earth, whereas your jet streams are your upper level winds. They act high in the atmosphere. Okay. All right, on the back, reminder that your ocean currents are stream-like movements of water in the ocean, and there are 2 types of ocean currents. You have surface currents and deep currents. Talking about surface currents, they are on the ocean surface down to only about 100 meters. Ocean currents that are surface currents are caused by winds, and there are a couple of factors that affect how surface currents work. One of them is the global wind pattern. 2 is the fact that they've got to move around the continents, the land, so continental deflections. And 3 is the Coriolis effect, causing winds that would like to go from one place to another, or currents that like to go from one place to another. They curve rather than going straight. Surface currents are powered by the sun. The 2 examples of surface currents that you needed to know were the Gulf Stream, which is a warm surface current. It's illustrated right here. It goes by the east coast of the United States. And then there's the California current, which is a cold water current, and it acts along the west coast of the United States. Okay. A gyre is a large circulation made up of several ocean currents, and typically they have both cold and warm water currents. So here, for instance, is the North Atlantic gyre. Here's the South Atlantic gyre, etc. Places at the same latitude can have different climates because, for instance, over here, this climate will be influenced by a warm water current, whereas this location on the west coast is influenced by a cool water current. Okay, so gyres are just those big circulations of ocean water that act over very large areas. Ocean currents transport matter, things, sand, animals, trash, etc., and they transport heat energy as well. Okay, so you also have 3 yellow keeper sheets. This one is my original, so mine's in color and it's on a sheet of graph paper. Yours is on a piece of yellow paper. But you need to read back through this. The sun provides the energy that drives convection currents in the world's atmosphere and ocean. Convection, remember, is the movement of fluid due to differences in density. And the differences in density is caused by differences in temperature. Things you need to know about convection. Warmer fluid always rises and cooler fluid always sinks. Warmer fluid rises because it's less dense. Cooler fluid sinks because it's more dense. Okay? Because when fluid is heated, it tends to expand. That's what makes it less dense. Fluid that is less dense rises. Fluid that is more dense sink. Fluids are anything that flows. Water is a liquid, and that's a fluid. Gases are considered fluids. Even magnet in the Earth's interior is considered a fluid because it can flow. Here are your reasons why the Earth's surface is not heated evenly. We've already gone over that with the other set of notes. Because the Earth's surface is not heated evenly, we have to take the excess heat at the equator and move it towards the poles, and we do that with global winds, ocean currents, and with storm systems like tropical cyclones. On the back of this keeper sheet is your information about winds and ocean currents. A lot of this is the same set of information that you have on your guided notes, so I'm not going to read all of this, okay? But make sure that you go through all of that. Now that we've done a quick review on convection currents and density, let's go back to this, the back part of this bell work from the other day. If you have a source of heat in one spot and a source of cold in another spot, well, fluid is always going to rise where you have heating, sink where you have cooling. So warmer fluid is going to rise here, and sink here. And so the convection current that is set up in this situation operates this way with the arrows. Okay? If I was going to set up something where the convection currents looked like A, where you had the sinking in the middle, you would have to have the ice cubes in the middle and the candles on the sides. If you wanted just one convection current, then we would set it up with just a candle on one side to make the warm fluid rise and ice cubes on the other side to make it sink. If we wanted to have just one cell and it was going the other way, we'd put the candle over here to make the warm fluid rise, and we'd put the ice cubes over here to make the cooler fluid sink. Okay, there's some other interesting things on the front of this one. You should have all of this written already. Let's take a quick look at the other two keepers that you've got, and then we'll do a few practice things and you'll be ready to go to start correcting. All right, this is another yellow sheet of yours about weather. Weather consists of many factors: temperature, humidity, which is how much moisture there is in the air, precipitation, air pressure, wind speed, wind direction, cloud cover, all of that. There's actually a little station model example back here to show you where each piece of information goes. Again, you've got more information about convection currents. I won't read that because we've already just talked about that. Most of the United States is between 30 and 60 degrees north, so most of our global winds are due to westerlies, so things generally go from west to east within the United States. Remember that we've got our climate being influenced by the cold California current on the west coast and the warm Gulf Stream on the east coast. All right, weather maps. Isobars are lines on the weather map that connect areas with the same air pressure. A blue H would indicate high pressure, and weather is usually nice and not a whole lot of clouds with high pressure. Low pressure weather is often cloudy and sometimes can be rainy. Okay? I will also say that generally speaking, you tend to have cloudy, rainy weather more often near frontal boundaries, like cold fronts. Okay? Speaking of frontal boundaries, your cold fronts are represented by blue lines with spikes. Spikes show you which way the cold front moves. A warm front is a red line with red humps, but again, the hump direction shows you which way the front moves. A stationary front looks like a little piece of each one. Stationary front just means that neither air mass on either side of that boundary is doing any moving. Air masses, we call warm air tropical, cool air polar. We call wet or humid air maritime, dry air continental. So we've got 4 basic types of air masses: continental polar, which is cold dry; continental tropical, which is warm dry air; maritime polar, which is cold wet air; and maritime tropical, which is warm wet air. In Texas, we have storms when dry air interacts with warm humid air from the Gulf of Mexico. Okay, I didn't test you over this, but a watch versus a warning. A watch is when we have conditions that are favorable for certain things to happen, and a warning means that it's actually happening or it's about to happen. Station model, just remember this because you'll be asked to interpret that. I'll go ahead and do that right now. So I'm just going to review, you guys. You had a weather map. It's not this map, but it was similar to this. You had your station models for certain cities. For instance, this station model, there were clear skies because this little circle is not colored in. The temperature was 84, and the humidity, or the dew point, was 41, which tells you that the air was pretty dry. It's kind of hard to read because it's smashed in with the line indicating wind speed and wind direction, but the temperature reading is right there. This frontal boundary right through here is a stationary front. This part of the boundary is a cold front, which means that cold air is moving in. This frontal boundary right here is a warm front, which means warm air is moving probably generally this way. These lines are isobars. I know that they're isobars because these numbers that are on some of them, those can't possibly be temperatures. They're too high for temperatures. Okay, so those are isobars connecting areas that all have the same pressure. Okay, so you also have a third yellow sheet that's a keeper. This is on the front. Tells you some general information about tropical weather. Your tropical cyclones. The least intense is a tropical depression, less than 39 miles an hour sustained winds. Tropical storms, that's when you name a storm, and that's sustained winds of between 39 but less than 74 miles an hour. And then it becomes a hurricane if it has sustained winds of at least 74 miles an hour. And then once it becomes a hurricane, it can be categorized as a Category 1, 2, 3, 4, or 5 hurricanes based on their wind speed. Okay, down here with tropical cyclone hazards, damaging winds, storm surge, heavy rain, and okay, the biggest thing that causes damage and loss of life are these two. The stuff that has to do with water, storm surge and flooding. Okay. All right, so you should be able to get started. I'm going to do this one thing and then I'll turn you loose. So if you see one of these tropical cyclone advisories, you just need to remind yourself what all of the information means. The storm name, if it's named, is here. The time that the advisory was put out, the number of the advisory. Current information, X or a little yellow dot marks where the storm is currently located. All of this is where they think it might go in the future. If you're asked about sustained winds, it's right there, and that will help you determine whether it's a tropical cyclone, a tropical storm, a hurricane, etc. Okay? All right, I think that information should help you get started.